So one of my academic interests is international coordination of governance of all kinds of different technologies. So I'm going to talk about that specifically with regard to gene editing tonight. And I was privileged to work on a project here with ISSP and the predecessor to Monica as the director, Mark Sainer, on a project we did looking at different models of international governance of various technologies. And so I'm going to talk about that as applied to gene editing as well as some other work I've done. But first I was asked to talk a little bit more about the National Academy of Sciences, which you've heard a lot about already tonight. U.S. National Academy of Sciences is sort of a whole suite of activities going on right now in this sort of general area. So there's a report that was just that was done on gene drives. There's one on GMOs. There's another one pending on sort of the future regulation. There's a workshop on gene editing for animals. But also in the human area, as was just described, there was an international summit in December. It was a fascinating 3-day meeting of people from all over the world and from a lot of different perspectives, where you had people arguing for germline gene therapy, or germline gene editing from a scientific or medical perspective, from an ethical perspective, even though the majority of people were against it. So at the end of that, there was 12 organizing members put out this statement that was in their name only. It was not the official position of the National Academy of Sciences. And instead, the National Academy of Sciences convened a study to do what Jason had talked about for the gene drives on human gene editing. What should be the position on that? And what was really interesting about this committee that was convened last December is it is very international in scope, very unusual for the U.S. National Academy of Sciences to have these people from all over the world. So there's people from USA, Canada, China, UK, Germany, France, Italy, Israel, and Egypt on the committee, which is really unprecedented for the U.S. National Academy of Sciences. And although our recommendations are directed mostly to the U.S. government, they also apply generically. And our report is expected to be done by early 2017. We just had our last meeting this last weekend, so we're finished, and we sort of just putting dotting the I's and crossing the T's on the report. We're going to go to peer review. The extensive peer review is going to go through starting in a few weeks from now. And we heard all kinds of, we had several open meetings in the United States and in Europe, where we heard from people from all over the world, from countries and governments, but also all kinds of advocacy organizations, scientific organizations, and various types of experts. So we got a lot of really fascinating information and a lot of conflicting recommendations and so on. So how we deal with that, you're gonna have to wait to January, but it was pretty a fascinating process. And this is our statement of task, and it's basically look at what are the real benefits, what are the real risks, put aside the hype and ask the question, what is real, what can be done now and in the foreseeable future, what are the ethical and policy and legal issues this raises, and then leading into my talk tonight, what about harmonizing at an international level? So at this point, I'll then put on my personal hat. I can't talk about the report from a merit, so I'm only going to talk my own perspective, not talk about the committee at all. But what was really interesting from the perspective of international harmonization, in the summit in December, the first 4 speakers, David Baltimore, who was the convener of the meeting, and then the presidents of the U.S. National Academies of Science, the Royal Society of UK, and the Chinese Academy of Sciences all gave the first 4 talks, and all of them just said that international harmonization is critical. So they didn't argue why that is, they just said it. And that was interesting because it's not that simple, as we've already heard a little bit about tonight. That there's a number of arguments for international harmonization: equal protection, discourage medical tourism, provide consistent requirements for people practicing in the area, minimize trade disputes, address transnational impacts like the gene drive example, prevent race to the bottom, and then this economy of scales for regulators. And these different arguments apply differently to different technologies and different applications. They're not uniform across the board. But there's a lot of arguments against international harmonization too. There's these different social, political, ethical norms, and sort of the question asked earlier tonight, that there is these differences in risk and benefit as well, that there's a benefit to have different countries experiment, sort of laboratories of democracy, and try different approaches, see what works. It takes a lot of time to develop international standards. Is that worth spending the time on? Are we better off just doing it in our own countries? It's very difficult once you have regulations in place for countries to back off of them. We're seeing that in the GMO context, for example. And so if you already have regulations in place, it's very hard to move off of that. And then you might not get compliance anyhow. And Francis Fukuyama, an intellectual in the United States, he wrote a number of years ago, you got to do the national regulation first and then the international harmonization. What's the problem with that? That's not going to work. Once countries have inconsistent regulations in place, you can't harmonize. No one wants to back down. And so I don't think that will work. We'd have to start right away. So we're at this moment right now where we have these brand new technologies and applications. If we are going to do international coordination harmonization, we would need to start right now. But we already have inconsistent regulations. You heard about Canada's regulations. Other countries like Germany, for example, have, don't allow any research on embryos. Other countries like the UK or China do allow it. So we have already inconsistent regulations in place. Some of those may be changeable. Netherlands just changed their policy pretty dramatically. Will some other countries be willing to do that? I don't know. But right now, we already have an inconsistent playing field. So one of the issues that Mark and I worked on, and I've done this with some other colleagues, is looking at sort of what are the models for regulation at the international level. And the traditional idea is to adopt a treaty. And treaties are just extremely difficult to do. I mean, we can see this on a huge problem like climate change, right? We've been fighting for 20 years to get a treaty in effect that works, and they're still not really there. But this is a clear major problem that's going to affect everything about our life. So to do a treaty on something like this would be really difficult to do. So the idea that Mark and I and some other colleagues have come up with is sort of to use what are called soft law. Look at other mechanisms other than enforceable treaties that you have to comply with, where you put forward substantial expectations, but you don't necessarily enforce them by law. But you have other ways of trying to leverage enforcement. And then maybe over time, these can become more hardened into more traditional law over time. So in looking at sort of models of this, so at the bottom, you could do a treaty-based harmonization. And we tried that with cloning. That was a very interesting experiment because no one is in favor of reproductive cloning, or very few people, certainly no governments are. And we couldn't get a treaty. It failed. The process failed because of all kinds of complications. So how do you enforce it? What should it cover? And so on. And so a lot of effort went into that over a 2-year period, and the whole thing fell apart. So to me, that shows that we're not going to have treaties on gene editing. And so we have to look at other models. So at the top, one of the things that Mark and I's research really identified in talking to regulators from different countries and interviewing them, as well as people from companies and NGOs, is that having regulators being able to talk to each other and know their names and be able to pick up a phone and talk to them turned out to be the most powerful thing a lot of regulators we talked to said was in terms of trying to coordinate efforts is to be able to know the people in these other countries working on the same issues that they can talk to and have regular meetings and so on. Nothing formal put in place, but just having that dialogue turned out to be extremely important. And this model is now being applied in a lot of different areas, nanotech and a number of others. I have a colleague working on a report for the OECD on this very issue of transnational networks and how it's being very effective in a lot of different areas. Another idea is using some kind of non-binding guidelines, principles, standards. So you heard of the Society of Stem Cell Research. They have guidelines for embryonic stem cell research. They're not mandatory, but in the scientific community, if you don't comply with those, you're going to lose your credibility, and journals won't publish an article unless you comply with them. So there's other ways to sort of enforce those other than laws. And then another mechanism is mutual recognition. You recognize the laws of the other country, the regulations. So these are 4 different models. And when we look at these 3 different major gene editing uses, there's the human medical, there's the GM crops and foods, and there's the gene drives. What is the thing we're worried about? Why do we need international coordination? They're very different for those 3 problems. So for human and medical, I think the biggest problem is medical tourism. You just maybe heard about the first 3 parent mitochondrial transplant baby born in Mexico. That was medical tourism. That's a clear big problem that if Canada bans this, you can just come to the United States and get this. For GM foods and crops, it's going to be trade conflicts. If we have global food trade, and if some countries have laws prohibiting some things and others don't, we're going to have huge problems. We're already seeing that in GMOs. And then finally, as Jason talked about in gene drives, probably the biggest problem is them crossing the boundaries. As he said, these political boundaries organisms don't respect that. So in sort of dissecting this problem a little bit more, when we see these 3 different major applications of gene editing, the problem we need to address is very different for the 3 applications. So what would be the best solution? And I just came up with this morning, so it's very off the top of my head, and I'm not sure about this, and some of you may have different thoughts, but to put it out there, for the human medical, I think maybe professional society guidelines, like the Stem Cell Research Network, basically, the bright line on germline versus somatic, or enhancement versus therapeutic, maybe that would be a very effective tool, or somewhat effective. None of these are perfect. On GMO crops, maybe risk assessment guidelines to try to at least have a common scientific basis for evaluating these products. And then for gene drives, I think maybe, I'd be interested in Jason's view on this, the regular dialogue model might be the best model to use. So I think when we talk about transnational coordination, it's a very complex problem that's very application specific, and these would be my initial thoughts on what model we should try to use to deal with those. Thanks.